Okay, welcome to part 2 of the Johnson autopsy. Well, looks pretty nasty once we get the head off it. There's enough of a gap that we've got a big oxide layer built up here. That was never going to work. They probably warped the head too. Looks like they got a replacement head from somewhere because it doesn't match the paint scheme of the engine itself. Plus it's spotless, it's never been used obviously, it's never been able to be used. So the cylinder head itself's probably okay, it just needs a damn good clean-up. Even the head gasket, given a good clean-up and a proper bolt down, would probably compress and work properly. Most of it hasn't even been compressed yet. It's pretty nasty. But yeah. The bores are pretty good, there's a few light scratches in them but nothing serious. And as I was saying before, you can see the exhaust ports are uncovered first, so all the pressure in the cylinder after firing goes straight out through the exhaust and is overcome by the pressure in the crankcase. So the pressure differential forces fresh fuel and air into there. Tiny bit goes out the exhaust too. That's one of the reasons why two-strokes aren't 100% efficient with their usage of the intake mixture. But yeah, they work quite well. Yeah, you can just see there, even though the intake is covered, the exhaust ports are open, so all that high pressure gas in the cylinder can just rush out into the exhaust manifold. And then as the crankshaft or the piston continues downwards, it uncovers these ports which have high pressure fuel and air mixture behind them, and that rushes into the cylinder and replenishes it, ready for the next upward stroke. And just before it hits top dead center, the spark plug fires and bang, pushes the piston back down again. And that happens on each cylinder every time it reaches top dead center. So it's just fire, fire. Sticky. You get the idea. That's why they're so loud. Hell of a lot of wear and tear in it. Not too bad. She's used, well and truly used, but it's not completely rooted. We'll find out for sure once I get the crankshaft and everything out. See how scored it is. These run roller bearings in their journals. You can't run plain shell bearings without decent oil supply, but roller bearings seem to survive on the fine oil mixture you get coming through with the fuel charge. And that's what the oil in the fuel does, it lubricates all your roller bearings and things. Okay, so I've got half the exhaust manifold off, and you can see half of it is water, which looks like this section here, cooling water, which has to be preheated by the exhaust gases. You don't want stone cold water going into something like this because it can crack cylinder heads and castings and things. Thermal shock. A lot of them, well, pretty much every outboard I've seen has a layer inside the exhaust manifold cover that transfers raw water up through the body, through the preheat and then into the cylinder block. It's sort of like a car engine. You don't want your radiator to go stone cold and then suddenly dump stone cold water into a 100-degree engine. Otherwise you crack things. So that looks like exhaust gas because it's all burnt. And that's an outlet there, so I'd say that's exhaust gas, and this side here is water, given the corrosion that's on it. So that'd be coolant. That'd be exhaust gas. Coolant, exhaust gas, as well as a bit of exhaust out through the bottom. That would be exhaust outlet too. So that goes on there. Yeah, of course. It's all sooty. So you've got exhaust gases and a bit of everything, probably a bit of spill water, return water coming out through the thermostat. Yeah, quite interesting. I'll get the rest of these bolts out and remove the rest of the cover. And probably separate the rest of the leg too. There is not much else in there. There's just a control for the lower unit gear changing, forward, reverse, and there's a tube for the water inlet. Okay, well that's the block stripped down. We got rid of the dirty old exhaust manifold. You clearly see the porting in it, pretty nice. Now I guess the next step is to take these bolts out and drop the crankshaft and piston assemblies. The conrods are bolted by the looks of it, so I should be able to separate the pistons from the rod, also the crank. Some of them aren't. A lot of the time you've got to press the crankshaft together with the conrods on it, but in this case we'll get away with removing them individually. Not much to it once you strip the actual block down. Very simple. Okay, so at the bottom end there, got the crankcase bottom cover off. Doesn't appear to be a proper seal in here, it just seems to be a gas check system. These grooves create a circular, or I suppose a circular pattern in the flow of gas that comes through them, and it stops any excess flow. So it's gas checked, no rubber seal or anything in here, rubber seal on there. Centre bearing is a split roller bearing race. Little rollers. End bearings seem to be a semi-sealed race. Actually, maybe even a grease-packed race. Looks like there's a metal seal. No, it's not a metal seal. They are open to oil from the crankcase induction. And conrod ends, as you can see, they're also a split roller bearing race. Fairly well worn. It's definitely seen some good use. So I've got to split these end caps in order to remove the crank anyway. It's not one of the models where you can pull the whole assembly out together. I've got to take these big ends off, main bearing caps. Okay, well that's the end of that one. Tons of little needle rollers floating around. Bits of bearing shell, crank. Looks like it's almost been spinning on that journal there. Cast iron or forged steel crank. Not half bad. It's the output shaft. Well, what's left of it. Badly corroded because that's on the water outlet side of things. I've got to get rid of that key. But that's a roller bearing race, as with the other end. Block, well, nothing too special, it's just cast alloy. Might do the test to see if it's magnesium, but I doubt it. Usually cast aluminum, not magnesium. Bottom half, plenty more needle rollers, and a couple little baby pistons. Very stubby, solid conrods though. Short stroke, plenty of displacement. And the piston crown design is to optimise flow through the cylinders. That's why they've got the raised section on them. Yeah, not bad. I'll keep the pistons as souvenirs and the rest can go in the bin. That's the end of that one. Thanks for watching.